Hi folks, we're going to take a look at the solution to number 3 from the worksheet on the geometric definition of the dot product. Okay, so they give us this piece of information. It's not quite clear what we're going to use it for, but it tells us that the magnitude of the sum of these two unit vectors is equal to root 3. And then it asks us to determine a value for this dot product here. Okay, so it's not much. This information can directly help me with the dot product of these two vectors, so best thing to do is to expand that out and see what it gives me. Okay, so again we saw that we can take the dot product in a similar way in which we can work with numbers and variables, so we can just distribute this in the same way. So we have 2u dot v, so we've got, that is 2u dot v, and then we've got 2u dot 3u, so that's plus 6u dot u. Then here we've got negative 5v dot v, so minus 5v dot v. And lastly, these two vectors here, we have minus 15v dot u. Okay, so let's simplify this. So here, first of all, I notice that I have u dot v and v dot u, but we know that the dot product is commutative. So u dot v is equal to v dot u. So this can just become 2 minus 15, which is negative 13 u dot v, or I could write it as v dot u, doesn't matter. Okay, now here I know that u dotted with itself, okay, or any vector dotted with itself is just the magnitude of that vector squared. And same thing here, v dot v, so that's minus 5 magnitude of v squared. Okay, so notice here how the magnitude is a number, so we can use this exponential notation, but when we're doing a dot product we do not use exponential notation, so we don't write this as the vector u squared, so keep that in mind. Okay, so let's keep going here. Well, I know u dot v. Well, we have a definition for that. We know that that's just the magnitude of u times the magnitude of v times cosine of the angle between them. Okay, now here the magnitude of u is just 1, so 1 squared is 1, so we just have plus 6. And similarly, v is also a unit vector, again, because of the hat. It's not an arrow, it's a hat, so we know that it's representing a unit vector, so this is just minus 5. Okay, and similarly here, these magnitudes are each 1, so I'm left here with negative 13 times 1 times 1 times cos theta. Okay, and 6 minus 5 is 1, so plus 1. And that's as far as I can go in simplifying using the algebra I have. Okay, so the question is what is the angle between these two vectors? And it looks like this is when that extra piece of information is going to come into play. Okay, because if I add these two vectors, so let's say this is vector u, okay, which of course has a magnitude of 1, and I add to that, I'm not sure exactly where it's going to be, vector v, which of course also has a magnitude of 1. Well, I know the magnitude of their sum, okay, which is equal to root 3. Okay, now remember what theta represents. It represents the angle between the two vectors. So I can look for this angle here, which is not in and of itself the angle between the two vectors, but of course it'll help me find the angle between the two vectors, because if I take this vector v and I just move it over so that the two vectors are tail to tail, okay, this is the angle I'm actually looking for, which is just supplementary to the one that's in the triangle. So I'll call this one phi, since I already used theta for the angle between the two vectors. Okay, and so now this is a fairly easy cosine law. Okay, so we have phi is equal to inverse cosine of, so its opposite side, so root 3 squared is just equal to 3 minus 1 squared, okay, that's supposed to be an equal sign, minus again 1 squared, which is just 1, divided by negative 2 times the two sides that are not opposite, so 1 and 1. Okay, and here I just have cos inverse of, so 3 minus 1, which is just 1, over negative 2, so I just have negative 1/2. Okay, now in case you don't recognize this, you stick it in your calculator, but hopefully you recognize that 1/2 is going to relate to special angle, so cos inverse of -0.5, and there we go, there's our 120 degrees. Okay, so there's 120 degrees, but of course theta then is just going to be the supplementary angle, so that's 60, and so now I can stick this into my equation here, or to my expression, so -13 times cos of 60 degrees plus 1. Okay, and what is cos 60? Okay, well, we should know that it's be very similar to what cos of 120 is going to be, but instead of -1/2, it's just going to be +1/2. So this is -13 times 1/2 plus 1. So here we've got -13/2 plus 2/2. So here we're left with -11/2, or -5.5. Okay, so again, just to recap what we used here. Number one was the algebraic tools that we have for dealing with the dot product, very similar to how we perform algebra with numbers and variables. Then from there, we use the fact that dot product is commutative. We use the fact that vector dotted with itself is just the magnitude squared. Okay, and then we use this information on how to add vectors to eventually find the angle between the two vectors. Okay, that's it for this one.